Hi everyone, I'm Babak. Today I'll be talking about bias in the context of decision support OLAP queries. This work has been presented at SIGMAT and demonstrated at VLDB 2018. Decision support technologies such as online analytical processing OLAP aimed at enabling the knowledge worker to make better and faster decisions. In fact, OLAP is the foundation for many kinds of business applications, ranging from business performance management, planning, budgeting, forecasting, to financial reporting and knowledge discovery. During the past few decades, the database community has been focused only on the performance requirements of such technologies rather than the functional requirement. In this talk, I'm going to show you that OLAP queries can be biased for making decisions, and no matter how big is your data and how fast you can process it, they may lead to incorrect business decisions. Let's start with a simple example. Suppose a company has many business travels from 4 particular airports and would like to choose between business travel programs offered by either American or United Airlines, depending on which one performs better in terms of on-time flight. Therefore, the decision here depends on the answer to the question that which airline has a better on-time performance. To make the decision, the company's data analyst uses the publicly available flight data and poses the simple OLAP group by query, which computes the average of delayed flights grouped by each of the airlines. As you see, the results suggest that American Airlines performed significantly better in these four airports. However, this conclusion seems to be wrong, because right after we further breaking down the flights delay by each airport, it turns out that it is actually United which performs better in each of the airports. That is, although the average of delay of American Airlines is lower than United Airlines in general, American Airlines has a higher delay at each particular airport. This phenomenon is known as Simpson's paradox in statistics and happens because of overlooking the so-called confounding variable. In this case, what the company really wants is the causal effect of choosing American or United Airlines on the delay of its travelers. However, the original query fails to answer this question because, as I will explain later, it is biased. The problem that we looked into in this project is the following. Given a group by query used for decision making, we detect whether it is biased for decision making, we measure and report the bias, and we repair automatically the query to remove bias. Specifically, we propose HypDB, the first database system which detects, explains, and removes bias from OLAP queries. Our contributions include a new and formal definition of a biased query, a novel algorithm to learn factors from data that leads to bias, novel techniques to find ranked explanation for the bias, and finally query rewriting techniques to eliminate the bias from queries. Instead of discussing the technical details, I'll demonstrate how HypDB handles the bias query from flight data that I showed you earlier.